Hi everyone, we're going to talk about vectors today. Let's start with defining a vector. A line that has magnitude or length and direction, which is the angle made with the positive x-axis is called a vector. For example, here I have my coordinate plane and this line is called a vector because it has a length and it also has a direction. The direction is the angle which is made with the positive x-axis. I could also have my vector in this way, for example. Again, it has a length which is magnitude and a direction. The direction here is the angle which is made with the positive x-axis. So this is the direction, not this little one. An example of vector could be velocity. For example, we'll say a car is going to the north with the speed of 50 miles per hour. So this velocity has a direction to the north and a magnitude of 50. So that's an example of vector. A line segment with a magnitude only is called a scalar. So it doesn't have any direction, it has only magnitude. For example, like temperature, or when we say someone is weighing 120 pounds, so that is basically a scalar because it doesn't have any direction. It's just 120 pounds. What are parts of a vector? So we can find parts of a vector from different points of view. If I have a vector here, the point that the vector is starting from is called initial point. Initial point. The point that the vector is ending is called terminal point. The length of this line is magnitude. And also it has a direction, which is basically the angle which is made with the positive x-axis. A vector also has two components. One is called x component and the other one is y component. Let me fix this for you. Component. Basically, we represent a vector with this little arrow on top of the name of the vector, and the components can be written in this form. So we put two kind of pointed brackets and write the x component first, then y component. We can also write the x and y components in this way. So I can say vector v is xi plus yj. So I means x component and j means the y component. So if I have this vector, the horizontal distance between the initial point and the terminal point is called the x component. And the vertical distance between the initial and the terminal point is called y component. For example, if I have a vector that has x and y components of 8 and 4, then we can write v is 8i plus 4j, or we can also write it in this form. V is 8 and 4. So these are the components of a vector. What does the magnitude represent? As we just talked about that, the magnitude is the length of the vector. How do we find vector, a length of the vector or magnitude of that? As you see here, we have made a right triangle using the x and y components. And the magnitude is the length of this line, which is basically in this triangle, the hypotenuse. So we know that using Pythagorean theorem, we can easily find the hypotenuse of a vector, hypotenuse of a triangle. So I'm going to draw that here again. If this is my vector, this is the x component, and this one is the y component. And let me call the magnitude, write the magnitude in this form. This is how we represent magnitude. The name of the vector in between two bars on each side. So this can be found using the Pythagorean theorem. So it could be a squared plus b squared under radical. So that's how we can find magnitude of a vector. For example, in this example that we had, vector v is 8 and 4. To find the magnitude of v, I can just take 8 squared plus 4 squared, add them, and then square root them. So this will be 64 plus 16, which is square root of 80. So that's the magnitude of this vector. Here we have another example. In this example, we have vector u, and the a value or the x component is 2, and b value is -3. So to find the magnitude of this u, I'm going to take each of the x and y components. So it will be 2 squared plus -3 squared. Notice that here the y component was a negative number. So I raise that to the power of 2. It will be 2 squared is 4, and -3 squared is +9. And this will be square root of 13. So that's the magnitude of this vector. You have some special cases of vectors. Unit vector is a vector with a magnitude of 1. So if you have a vector that the length of this vector is 1, that's called a unit vector. Zero vector is a vector with no direction and magnitude of 0. That means if I have, for example, here as my initial point of the vector, the terminal point also is going to be on the same point. So we have basically just one point, because there is no direction and there is no length. So it's just one point. What is a position vector? A position vector has an initial point on the origin. For example, let's draw a vector here. Let's say I have a vector which starts at -2 and 5 and ends at 3 and 7. So I'm going to find the vector here, graph the vector here first. -2 and 5 is the initial point. -2, 1, 2, 3, 4, 5 is here. This is the initial point. And the terminal is at 3 and 7. 1, 2, 3, 5, 6, 7. So it's going to be somewhere like this. So this will be the graph of the vector. But what is my position vector? Position vector is this vector when it starts at the origin. Means I need to move the starting point to the origin. Now this is going to be my new vector. How do I find the x and y component of the vector? If this was my original vector, I know that because this is -2 and 5 and the terminal is 3 and 7, so I have to go 5 to the right from -2 to reach to 3. So the x component is 5, and I have to go 2 to the top, to the up actually, to reach to 7. So that's my y component. So basically, if I move the initial side to origin, I need to go again 5 to the right and 2 to the up to go to the terminal point. So my position vector will be 5 and 2. So that's a position vector. Basically, when you're given a vector, for example, v is -3 and 4, and you want to graph the vector, you're just going to graph the vector by starting from the initial, from the origin. So -3 and 4, that means I have to go 3 to the left and 4 to the top to find the terminal point. So starting point is negative, is at 0 and 0, and the terminal point is here. So this will be the vector. Usually we graph our vectors starting from the origin. Okay, so let's go to the next part. Let's talk a little bit more about horizontal and vertical components. So we said if we have a vector, the distance between the initial point and the terminal point, like horizontal distance, is called the x component. Let's call that A. And the vertical distance between initial and terminal is called B. Also, we know that a vector has a direction the direction is the angle made with the positive x-axis. So let's call that theta, and also has a magnitude. So if this is my vector, the magnitude can be written in this form. We said we write the name and put them in between two bars from each side. Okay, so this angle is the direction of the vector, and the length of this line is the magnitude. And we just learned that the magnitude can be found using the Pythagorean theorem. So it's square root of a squared plus b squared. Okay, now let's try find cosine of theta using this right triangle that we have here. Cosine of theta we know is adjacent over hypotenuse. Adjacent side is a, and the hypotenuse is the magnitude, which is this. And also sine of theta is the opposite over hypotenuse, which is the magnitude. So it will be b over magnitude. Okay, from here I can find the x component of this vector. So x component of the vector is magnitude times cosine of theta, because I can just do cross multiple. You can set a denominator of 1 here and do cross multiple. Then a times 1 is a, and magnitude times cosine of theta is going to go to the other side. The same here. Set the denominator of 1 and cross multiple. Then b will be magnitude of v times sine of theta. So these two equations are the formulas to find the x and y component of a vector using the direction and the magnitude. So if you have the direction and the vector and magnitude of the vector, you can find the x and y components of that vector. So here we are going to do an example. A vector has a magnitude of 8 and a direction of pi over 3. So the direction is the theta that we have, and 8 is the magnitude. Sometimes we can just write the magnitude as r. It's just a name. You could also write, if the vector is called v, you can write the magnitude in this form, or just make it easier and just write r. Okay, so here the magnitude is 8 and theta is pi over 3. Now we want to find the horizontal and vertical components in I plus j form. That means we are looking for a and b, and we want to write it in this form, ai plus bj. So the vector could be written in this form. We just learned that there is a formula for them. If I have the magnitude and the theta, I can easily find x and y component. So A will be magnitude times cosine of theta, and B will be magnitude times sine of theta. So this will be 8 times cosine of pi over 3, and B will be 8 times sine of pi over 3. So the only thing we need to know here is cosine of pi over 3 and sine of pi over 3. If you have forgotten how to find them, I'm going to explain for you here how you can find sine and cosine of pi over 3. First of all, if we have theta equal to pi over 3, this is in radian. In degrees, it will be 180 divided by 3, which is 60. So the theta here is basically 60 degrees. So I'm going to draw a triangle with the angles of 60, 30, and 90. So if you remember, this is a special right triangle, and there were special ratios for that, for the sides. The side opposite 30 is 1, opposite 60 is radical 3, and opposite 90 is always 2. These are the ratio of the sides in a special right triangle of 30, 60, 90. Now, to find cosine of pi over 3 means cosine of 60. That's adjacent over hypotenuse, so it's 1 over 2. So this is 8 times 1 over 2, which is 4. Sine of pi over 3. Sine is opposite over hypotenuse, so it's radical 3 over 2. 8 times radical 3 over 2. So you can simplify this. It will be 4 radical 3. So vector V is 4i, because that was the x component, plus 4 radical 3j. That's the answer. Let's do another example here. This time, we already have the vector in I and j form, and we want to find the magnitude and the direction. That means we want to find r and theta here. So we know that A is negative radical 3 and B is 1, because here we don't have any number. That means it was basically 1. So to find the magnitude and direction, first of all, let's find magnitude. We know that magnitude, or we call that r here, is a squared plus b squared under radical. So that will be a component, which is negative radical 3 squared, plus b component, which is 1. And then we take the square root of that. So negative radical 3 squared is just 3, because you know negative radical 3 squared is negative radical 3 times itself. Negative and negative, they cancel each other, and also radical times radical also cancel. It will be just a 3. Plus 1 squared is 1, so square root of 4, which is 2. So we found the magnitude, which is 2. Now we need to find the direction. That means the angle that the vector is making with the x-axis. So in order to find that, I'm going to graph my vector. The x component is negative radical 3, so we need to go to the negative side on the x-axis. So let's say this is negative radical 3. And then the y component is 1. That means we need to go 1 up. Let's say somewhere around here. So this is 1, and this is negative radical 3. And this is going to be my vector. The length of the vector is 2. That's what we just found. Now the direction is the angle which is made with the positive x-axis. So this is the theta that we're trying to find. But how do I find that? I can use this triangle to find this angle, because here I have a right triangle, and as you see, the ratio of the sides are ratio of a special right triangle. which is 2, 1, and negative radical 3. So I can find the angle. The side that is 1 is opposite angle 30. So this is 30 degrees, and the rest of that is going to be 180 minus 30, which is 150 degrees. So theta is 150 degrees. Let's do another example here. A wagon is pulled with a force of 15 pounds at an angle of 30 degrees above the horizontal. So this is what we have. We're pulling that with a force of 15 with an angle of 30 degrees with the positive x-axis, like this, something like this. This is 30 degrees. So basically we have the vector, and let's call that f. We have the vector f that has a magnitude of 15 and direction of 30 degrees. Now we want to find a and b and write the vector in terms of x and y component in this form. So this is what we're looking for, because it says express the vector f in terms of its components, x and y components. Okay, so we know that a, using this formula that we just found here, is equal to the magnitude of f times cosine of theta. The magnitude is 15 and cosine of 30 goes here. And b is magnitude of f times sine of theta. 15 times cosine, sine of theta, which is 30 here. Okay, so what is cosine of theta? Again, we can use the same triangle that we had here. A triangle which has angles of 30, 60, 90. The side opposite 30 is 1, opposite 60 is radical 3, and opposite 90 is 2. Okay, so sine of theta will be opposite over hypotenuse, which is 1 over 2, and cosine of theta is adjacent, which is radical 3 over hypotenuse. So cosine is 15 times radical 3 over 2, and sine will be 15 times 1 over 2. So x component is 15 radical 3 over 2, and y component is 15 over 2. I can write f in this form, 15 radical 3 over 2i plus 15 2 times j. That's the vector. Now I'm going to explain to you how to do your homework. The first problem says find x and y components of the vectors that you see here. For example, the first one, because it's starting at the origin, so you just go 3 to the right and 4 to the top to find x and y component of this. So it's just 3 and 4. For this one, you have to go 1, 2, 3 to the left. So it's going to be negative 3 and 1, 2, 3, 4 to the top to go to the terminal point. So it's negative 3 and 4. For the next problem, says find the magnitude of these vectors. To find the magnitude, you just need to use the formula that we had for a vector. So you take a, like here is 2, and b, which is 5, and use them in this formula, a squared plus b squared, and find that. Notice that in this one, b is negative 3. And if you just raise it to the power of 2, the negative will go away. So it will be just b squared will be negative 3 squared, which is 9. And then you find the magnitude. For this problem, a vector has a magnitude of 7 and direction of pi over 6. So this is the magnitude and this one is theta. So to find a and b, we want to find the x and y component and write it in I and j form. You just use the formula r cosine of theta is going to give you the x component, and r sine of theta gives you the y component. The same is for the next problem. And here we already have the components in I and j form, x and y component. We want to find theta and the magnitude of the vector. So we know that if we have a vector like this, we need to go 2 to the right and 3 to top to go to the terminal side. And in order to find the theta here, I'm going to use this triangle. But since we don't have a special right triangle here, I can just use the inverse function. We know that tangent of theta is opposite over adjacent. So it's 3 over 2. So from here, theta will be tangent -1 of 3 over 2. You can use your calculator to find the exact value of that. And to find the magnitude of v, you can just use the formula a squared plus b squared and find that. So I'm going to ask you to do the rest of the problems by yourself and practice to learn more. Have a good day.